So welcome to Noble of Chemistry channel. So today we're going to see the topic. It is haloalkanes and haloarenes. Chemistry syllabus present remaining conversions. Already first part of the conversions over. Now remaining conversions. Clear listen panikunga students. Then 2-chloropropane to the first conversion. It is that N2-chloropropane into and 1-propanol. One propanol, 2-chloropropane into 1-propanol. Okay, right. So first we want to write the structure of 2-chloropropane, CHCl, then CH3. So we need 1-propanol. So first we want to do that dehydrohalogenation. Previous class already I explained what it is that while doing the dehydrohalogenation, what we want to adding the reagent, that is the alcoholic KOH. While adding the alcoholic KOH, that is the dehydrohalogenations will be takes place. So here it is that in chlorine, that is this chlorine and this hydrogen, it is replaced from here, and to the formation of the product as, and we will get it as a product CH3, then CH double bond CH2. Okay, propene, 1-propene we will get. Next, we want to do again halogenations, and that is that hydrohalogen addition. Hydrohalogen. For my convenience, I am adding the hydrobromination. This is the H plus and this is Br minus. And I want added the bromine in the first carbon. For that, I followed that anti-Markovnikov rule. So for that, I used as a reagent this hydrogen peroxide. That it is follows that anti-Markovnikov rule. Okay, this negative part, it is according to anti-Markovnikov rule, negative part added into the carbon containing, it is that carbon containing, it is more number of hydrogen atom in the active site. Hydrogen it is going to add it. Okay, so next we want to write the complete the product. Then we will get it as a product. We'll get it as a product as 1-bromopropane. So next we want to do that instead of that alcoholic potassium hydroxide, we added into that in aqueous potassium hydroxide. What is the role of aqueous potassium hydroxide? Simply substitution reaction. Okay, this will be replaced from here, and it is a replacement of what? It is replacement of KBr, and we will get it as a product as CH3, CH2, CH2OH. That is, we will get it as 1-propanol. This is like a conversion we want to do. Next case, next conversion. And isopropyl alcohol into iodoform. Isopropyl alcohol into iodoform. Isopropyl alcohol, right? First, we want to draw the structure of isopropyl alcohol. Isopropyl alcohol to iodoform. Right. First, we want to write the structure of the isopropyl iodide, right? And how we can write it is that isopropyl alcohol, right? CH3, then CH3. Like this, be present means this is called as a isopropyl alcohol. So now it is OH group, it is added to here. The first we want to do that iodoform reaction. Iodoform as a product means definitely we need the methyl ketone. So how we will get it as a methyl ketone in this simple oxidation reaction? This is the secondary alcohol. I'll do the oxidation in the presence of potassium, acidified potassium permanganate, and we will get it as that secondary alcohol oxidize panamna, we will get it as a product as ketone. This is the ketone, methyl ketone. Next, it is followed that is first step, we will get it as a methyl ketone. Then next step, what we want to do means this ketone, that is a reaction with that and iodoform reaction. So iodoform reactions, what are the conditions of the iodoform reaction? And we add sodium hypoiodide, sodium NaOI. Okay, so this group, it is going to breaking and to the formation of the compound. This is the mild oxidizing agent. Okay, that is that this will be converted into CHI3. One of the product, it is iodoform. Another product, this ketone, it is get oxidized into acid. Okay, upon this CH3COO and combined with that sodium oxide. Okay, we will get it is a product as sodium ethoxide. So our main product, it is the iodoform. So here it is that isopropyl alcohol, it is converted into iodoform. Okay, this is the another conversions. Next we move on to that, and next conversion, chlorobenzene into para-nitrochlorobenzene. Okay, that is chlorobenzene into para-nitrochlorobenzene. That is para-nitrochlorobenzene. Okay, chlorobenzene. I write chlorobenzene. First, we want to write the structure of the chlorobenzene, right? And the simple nitration process only. That is simple nitration, chlorobenzene. That is in the presence of, it is nitric acid and sulfuric acid. We will get it as the compound as para-nitro. Ortho also will be formed. That is a major product as the, and para as the major product. Okay, this is that para-nitrochlorobenzene. So chlorobenzene, we can easily convert it into para-nitrochlorobenzene, right? Okay, this is the conversions. And next we move on to the another conversion. And second, right? Next, it is that another conversion. It is 2-bromopropane to 1-bromopropane. Okay. First, write the structure of the 2-bromopropane. 2-bromopropane. This is 2-bromopropane to 1-bromopropane. We will get it as already, that is that 1-bromopropane into 2-bromopropane. Already we are completed in the previous video. Here it is 2-bromopropane into 1-bromopropane. What we want to do now? First, we want to removing the dehydrohalogenation and write the structure. And 2-bromopropane. Second position, bromine, then bromine. Methyl. Okay, that is what we want to do in the presence of alcoholic KOH. Keep it in your mind, students. Alcoholic KOH that is dehydrohalogenations will take place, and bromide atom, it is removed from this carbon atom, and the hydrogen atom, it is removed from any one of the methyl group. Okay, we will get it as a product as, right, CH3, then CH double bond CH2. This is that 1-propene, right? Okay, next we want to do that simple hydrohalogenation, that is in HBr addition. Okay, so that is that, and bromine, I want to add it in the first carbon. So what I want to do now, it is we follow that anti-Markovnikov rule. If it is following the anti-Markovnikov rule, it is the reagents we used as, it is hydrogen peroxide as a reagent. Okay, that is that according to anti-Markovnikov rule, this negative part, it is going to add it into the carbon containing more number of hydrogen atom in the active site. Okay, hydrogen we going to add it to here, and we will get it as a product as, and CH3, then CH2, then CH2, then Br. We will get it as a product as 1-bromopropane. So that is the easiest way of converting that 2-bromopropane into 1-bromopropane. Okay, right. Next one. Next conversions, it is chloroethane into butane. Okay, that is that chloroethane. The formula for chloroethane, this is my chloroethane formula. chloroethane, that is converted into butane. What we want to do now? 2, it is converted into 4 number of carbon means definitely we follow that Woods reaction, right? Okay, upper 2 carbon atom here, but in our product, that is that we will get it is that is butane as a product, no? Upper, that is a 2 carbon that will be converted into 4 carbon atom means definitely don't worry, that is 2 plus 2 converted into 4 means definitely you follow that and Woods reaction. Okay, that is, this is my chloroethane, that it is reaction with that sodium metal, 2 sodium metal. Also I want to add it in the another chloroethane, right? And so here it is that, and the chlorine, it is replaced from here, and we will get it as a process product as, and in the presence of the Woods reaction, it is takes place in the solvent, it is dry ether as a solvent, and we will get it as a product as butane as a product. So we just write it is joining the all alkyl group in the both sides. Okay, here it is ethyl, one ethyl group, here it is other, here it is one another ethyl group, it is there. We just joining these 2 ethyl group and we will get it as a product as a butane. Okay, and next conversions, and benzene to diphenyl. Okay, this is also like this reaction only. It is benzene converted into diphenyl. Okay, benzene, it is converted into diphenyl. What we want to do now, it is that, and first this is the important, that is also similar naming reaction, but it is that followed as a phytic reaction, because aryl chlorine. First we want to do and benzene, that is followed by an halogenation. What we want to do, suppose I added into the chlorination means in the presence of Lewis acid, FeCl3. Okay, we will get it as a product as chlorobenzene. In a product, we will get it as that product as chlorobenzene. After it is getting the chlorobenzene, next it is following the phytic reaction. Okay, so here also in the phytic reactions also, I want to add it in the 2 moles of benzene. Okay, one second. And yes, next one. Yes. One second. Okay, again we will start the reaction. It is because the space it is not sufficient, and the reactant it is and benzene into and chlorobenzene, right? That is, and first we want to do that benzene, that is converted into chlorobenzene in the presence of chlorine and FeCl3 Lewis acid we have to add, and we will get it as a product as N2-chlorobenzene. After it is getting the 2-chlorobenzene, this it is undergoing, it is phytic reaction. Okay, both are, it is alkyl chloride means, and for that I require it is 2 moles of chlorobenzene in the presence of, it is 2 moles of sodium atom. So these two are, it is reaction with each other. These two are, it is reaction with each other, and the replacement of sodium chloride, that is also 2 moles of sodium chloride will be replaced from here, and we will get it as a product as biphenyl. So 2 phenyl group, it is attached with each other, and with that is the product, it is called as a biphenyl. This is the biphenyl product. Okay, next, and tertiary butyl bromide to isobutyl bromide. So first we have to write the structure for the tertiary butyl bromide. Okay, tertiary butyl bromide. Tertiary butyl bromide, right? This is the structure of tertiary butyl bromide. And This is the structure of tertiary butyl bromide. So that is, it is converted into what? Isobutyl bromide. Okay, that tertiary butyl bromide, it is converted into isobutyl. So how we can write? That is CH3. This is iso. This is iso and butyl. So one more carbon atom we have to add. This is, so conversion from, it is a tertiary compound into the primary compound. So what we want to do now, the first we want to do the case in alcoholic replacement, tertiary butyl bromide. Bromide, no, so we have to add here this Br. Okay, tertiary butyl bromide into isobutyl bromide. So here also bromide only. Sorry, it is that here also bromide only. Right. So first we want to write the structure of the tertiary butyl bromide. This is the structure of tertiary. In this tertiary butyl, it is bromine we have to add. First what we want to do, it is that because bromine, it is in the displaced position. Right. That is replacement of bromine, that we have to add alcoholic potassium hydroxide. Okay, alcoholic potassium. What's the role of alcoholic potassium hydroxide? It is a dehydrohalogenation. Okay, that is a beta elimination will takes place. Here it is that this is also, this is my alpha carbon. This is also beta carbon. This is also beta carbon. So anywhere from, because both it is same only. So from anywhere we can replacing the hydrogen atom and we will get it is a 2H. Okay. So for my convenience, I can write this carbon CH2. Okay. So from this, I want to removing that hydrogen and bromine. So this is HBr. It will be replaced from here. It's minus HBr. And we will get it as a product as in the first step, we will get the product CH3, then CH3, then double bond CH2. Okay, so this is the first step product. So next step, what we want to do now, it is that and hydrogen addition, hydrobromine addition. Okay, this is the double bond step. Simply that is the HBr addition. Where we want to add the Br? In the first carbon. In the first carbon. In the first carbon, we want to adding the Br means then we have to follow the rule as anti-Markovnikov rule. Anti-Markovnikov rule. So if we're following the anti-Markovnikov rule, what are reagents I want to select? It is a peroxide as a reagent. Okay, here it is H plus and Br minus. This Br minus we have to add it in the carbon containing more number of hydrogen atom. That is hydrogen we going to add it here and we will get it as a product as CH3, then CH, then CH3, and this is also, it is converted into CH2Br. Okay, so what is our final product? This is the 2-methyl-1-bromobutane. Okay, or it may be, it is the isobutyl bromide, right? Okay, so this is the easiest way of getting, it is tertiary butyl bromide into isobutyl bromide, right? And next conversion process. Next conversion. In aniline into phenyl cyanide. Okay, aniline into phenyl. First, we want to draw the structure of aniline. At this aniline into phenyl cyanide. To phenyl cyanide, right? Phenyl isocyanide. Sorry, it is not a phenyl cyanide. Phenyl isocyanide. How to converting that? First, we want to draw the structure of aniline. Benzene bonded with NH2, that is we called as a aniline. Don't forget, benzene with NH2, that is aniline. That is reaction with that chloroform. What's the formula for chloroform? CHCl3. That is also reaction in the presence of KOH, alkali medium. So either we can use this NaOH or it maybe we can use the potassium hydroxide. And it is simple heating or it's simple warming, and we will get it as a product directly. We will get it as a product as that is isocyanide. So they are asking only the simple conversion. So no need to draw the mechanism for this. And this is the formula for isocyanide. That is simple process. So that is the important reagents we have to add it here. One of the reagent it is chloroform, another reagent it is potassium hydroxide. So from these two reactions only we will get it is that it is isocyanide as the product. Okay, this is the important. Okay, children, this is the important naming reactions in the haloalkanes and the haloarenes. Already we are completed, because the students are, it is very struggle to work out in the and conversion problem. Okay, so this is what's the complete video, that is how the conversions will take place. Okay, so don't forget students, so this is that, and coming 22 and evening, so you have a chemistry English examination. All the best for your examination. And the same day evening, 22nd evening, it is 6 to 8 o'clock. It is have a free online class for aldehyde ketones and carboxylic acid. Complete discussion, the how the questions we coming for board examination, and what a method of workouting the problem in the easiest way. So that now we going to discuss in the that particular live classes. You join in the particular live classes, and so I giving a mail registration Google form ID, as well as is the registration email ID also, and as well as it is I giving a Zoom meeting ID. By using that Zoom meeting ID and password, you just attending the classes on 22nd and evening 6 to 8 o'clock. 6 o'clock to 8 o'clock. That is a 2-hour section. That 2-hour section completely free class. Okay. Thank you. We will meet again in the and that aldehyde ketone carboxylic acid classes. Thank you.